Today we'll discuss about protocols and standards. What do we mean by protocols and standard, and how does it help in computer communication or network data communication? Now, if we look at these protocols, protocols are a set of rules that control data communication between two or more communicating devices. Now, it is very important that there are a set of rules, okay, a set of rules that governs or that controls data communication. So without this set of rules, we cannot have proper communication. So this set of rule is very important in data communication. So when you have this set of rules, then what happens is that both the communicating device, if there is a communication between A and B, then this A and B should follow that set of rules in order to have a data communication or data transmission. Unless they follow this set of rules, if these two communicating entities do not follow the set of rules, then there cannot be communications. So these entities in a network must agree on a common protocol. So protocol is what? It is a set of rules. So in order to establish or to have a communication process, this set of rules, or which is also known as protocols, has to be established first. A and B must agree that we will follow X protocol or Y protocol in order to have communication. Then only we can have communication. Now, it is very simple. Like as in human communication, when we talk to each other, when A and B is speaking to each other, we have to speak in a language that A and B both understood. So if A is speaking, for example, English only, and B is speaking, for example, Hindi only. Okay, and B could not speak English and A could not speak Hindi, then there will be no communication between the two. The two can never communicate. So similarly, in data communication also, the communicating entities, the A and B or more, have to have a common language or a common protocol. For example, if A and B both speaks English or both Hindi, they may agree that, okay, we will speak in English, then they can have a communication between them. Both of them are using English. As I am using English to communicate to all of you, so accordingly, there can be a communication between the two entities. So protocol is something like language that we use in human communication. But in this case, these are a set of rules that governs data communication between the communicating devices. So what does the protocol do? The protocol defines certain things. What is to be communicated, that is defined by the protocol. How it is to be communicated, then when it is to be communicated. So this how, what, and when is very important. So the set of rules or the protocol defines what, how, and when is to be communicated. So that is what protocol defines in order to have a communication between two entities in a network. Now, this how, when, and what is also known as syntax, semantics, and timing. So what is syntax? Protocol defines the syntax. So syntax is what? The structure or format of the data or the order in which data is presented. Now, syntax, when the syntax of a communication is defined, it is about the structure. So if a data is to be transmitted, what should be the structure of data? In what format it is to be, if the data is to be transmitted, or in what order the data is to be presented. For example, a protocol may define that the first 8 bits, okay, the first 8 bits to be the sender's address. For example, we have streams of bits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, okay, 8. Then we may have 1, 2, 3, 4, 5, 6, 7, 8. For example, this is a stream of bit which has to be communicated. In this example, the protocol may define that the first 8 bit, that is from here to here, the first 8 bit is to be sender's address. Okay, the sender's address. This is to be address, but the address of the entities that sends the data. And for example, then it may also be that the next 8 bit will be the receiver's address. So it is agreed that the first 8 bit is going to be the sender's address, and the next 8 bit is going to be the receiver's address. So A and B, the communicating devices, understood that the first 8 bit is the sender's address, the next 8 bit is the receiver's address. So they are not the actual data. So the remaining, for example, the remaining can be the remaining streams of data that follows this first and second 8 bits. The remaining portion will be the actual data. So accordingly, A and B, which is communicating, will treat that these streams of bit contains sender's address, which is there in the first 8 bit, receiver's address, which is there in the next 8 bits, and the rest are the streams of data. So this is one example of the syntax, the structure, the format, or the order in which data is presented. Now we have the semantics. So the semantics is about the meaning of each section of bits. So interpretation of a particular bit pattern and action to be taken based on the interpretation. Now this is about the bit pattern and what action has to be taken on the basis of how this bit pattern is interpreted. Now, for example, does the address specify the route, or does it specify the destination only? So thus it means that sometimes we may have different routes. When A and B is communicating, they may follow different routes. For example, there are C and D also. So they may follow this route, they may follow this route. So sometimes the data that we are sending also mentions that these packets should go via D, or it may go via C, or sometimes it may not have that. It simply says these packages meant for B. So that kind of thing is what we call semantics. Now the next one is timing, which is very important. So timing is about when to send data and how fast. When and how fast, the speed at which the data should be transmitted. Now, for example, there could be a problem that the sender A is sending data at a speed of 100 Mbps, but the receiver process only at 1 Mbps. So what will happen is that the receiver will be drowning in the data. That means there will be data overload. The receiver will be overloaded with the data because it comes in 100 Mbps, but it is processing at 1 Mbps only. So definitely there will be overload. So if there is overload, then so much of data loss will be there. The data which could not be processed will be lost in the transmission process. So therefore, in protocols, these three things are very important: syntax, semantics, and timing. Now let us come to standards. Standards give us guidelines. Give guidelines to manufacturers, for example, and vendors, government agencies, and other stakeholders to ensure that the national and international interoperability and compatibility of data and telecommunication technology and process. That means uh, today data communication is not restricted to a small location. It is not restricted to a small uh, district or a small or within a state or within a country. It is worldwide. Therefore, we need which will tells us that a particular devices or particular software that will be used in the communication will be interoperable. That means they should be compatible. Okay, so that unless there are compatibility, then data and telecommunication technology cannot take place worldwide. Therefore, this is very important. And standards ensure, standard is like it's like a guidelines, or it's like specifications. Okay, so that tells us that what should be the technology that we are using it. Now, in data communication, there are basically two important standards. One is de facto standards, and the other is de jure standards. Now, what is de facto standards? De facto standards are standards which are not approved by or an organization or a legitimate body like the government body, but which are already adopted through popular usage. Now sometimes it becomes so popular. For example, that a mobile phone, for example, your mobile phone will look like this. It has become a standard. No country has given a rule or a law that mobile phones should look like this, but still mobile manufacturers are using this. This kind of structure. Why it is not curved? Maybe we can have something like this. But due to popular usage, people prefer this. So accordingly, the manufacturers, the vendors follow this standard, and accordingly today we have so much of a phone like this. Earlier we used to have phone which are slightly curved with a screen and all, which looks like a little bit like a banana. So we have that kind of phone also. But ultimately we are coming to this what we call smartphones, which is basically the whole thing is screen. So this is becoming a de facto standard through popular usage. Now, what is de jure standard? De jure standard is a standard which is approved by a legitimate or a recognized body. So if a standard recognized body says that we have to follow a certain standard, that standard becomes rule. We cannot go against this kind of de jure standard because these are legitimate standards. Suppose Telecom Regulatory Authority of India says that calls will be charged by seconds, not by minutes. For example, call charge will be calculated based on how, in terms of seconds, not by minutes. For example, if TRAI, Telecom Regulatory Authority of India, says that, that becomes a legitimate standard or a de jure standard that every telecom companies have to follow it. So that is the difference between these two standards. One is the de facto standard, the other is the de jure standard. Now let us come to the standard organizations. There are so many standard organizations which are responsible for the development of standards through the cooperation among various bodies. For example, we have standard organizations, we have forums, then even regulatory agencies also, then and so on. So all of these are responsible for creation of standards. Now, the first type of standards, probably the most popular is the Standards Creation Committee. There are various standards creation committees. Many organizations are dedicated to establishment of standards. Data telecommunication rely primarily on those published by the following. For example, this is popular in North America, and I believe that it is also the standards published by these organizations, committees, are accepted worldwide. The first is International Standard Organization. This is a multinational body. That means multiple countries are part of this standard organization. This membership is taken mainly from standard creation committees of various countries throughout the world. Now, the International Organization for Standard is active in developing cooperation in the realms of scientific, technological, economic activity, and so on. These committees, ISO, is responsible for so many standards. It is not only responsible for standards in telecommunication, but they are also responsible for so many other standard organizations. Standards, for example, hospital standards, or ISO standard in vehicle manufacturing, ISO standard, and so many. They look into various other standards. So they are responsible for. Their job is for coming up with standards of various things. One of them happens to be telecommunication. The next one is International Telecommunication Union, Telecommunication Standard Sector. So this was by the early 1970s, a number of countries were defining national standards for telecommunication. But there was still little international compatibility. So therefore, the United Nations responded by forming a part of its International Telecommunication Union, the committee, the Consultative Committee for International Telegraphy and Telephony. So this committee was devoted to research and establishment of standards for telecommunication in general. So therefore, this is a UN body. So this is also responsible for making standards, creating standards. Now in America, why I brought in this American Standard Institute is a country-specific standard institute, but they are responsible for making many computer or telecommunication-related standards, which becomes accepted or adopted worldwide. So this is this American Standard Institute, or in short, ANSI, is a completely private. Okay, it is not a government-owned institution, committee or organization. Private non-profit corporation, not affiliated with the federal government of the United States. However, all ANSI activities are undertaken with the welfare of the United States and its citizens are given primary importance. So similarly, we have in India also BSI, formerly known as ISI, Indian Standard Institute. I think now has been converted into Bharat Standard Institute. So they are the equivalent of the ANSI, American Standard Institute. So they are, BSI is responsible for looking after the standards of various things in India. Then we have this Institute of Electrical and Electronics Engineers, more popularly known as IEEE. So the institute, this institute is the largest professional engineering society in the world. The scope is international, it's not country specific. Its aim is to advance theory, creativity, and product quality in the field of electrical engineering, electronics, radio, as well as in all related branches of engineering. So they oversee the development and adoption of international standard for computing and communication. Then we have the next standard creation committee, like the Electronic Industries Association, in short IEA. So this is a non-profit organization devoted to the promotion of electronics manufacturing concerns. So IEA has made significant contribution by defining physical connection interfaces and electronic signaling specification for data communication. That is where IEA is more important. Then besides these standard creation committees, we also have various forums. I have not mentioned any specific forums because there are so many forums. Okay, so standard committees are procedural bodies and by nature slow moving. Okay, they are slow because they have to follow certain procedures. So to accommodate the need for working models and agreements and to facilitate the standardization process, many special interest groups have developed their own forums made up of representatives from different interest groups. So there are so many forums. I mean, you even have, for example, Microsoft Forum, for example, or you may have Microsoft User Forum or Android User Forum, or maybe C++ Programmer Forum. I mean, you have so many forums, but they are also equally responsible for maintaining standards or bringing up and coming up with various various developments in telecommunication. Then after that, you have regulatory agencies. For example, in America, you have Federal Communication Commission, which is responsible responsible in the protection of the public interest by regulating the radio, television, and wire or cable communication. Similarly, we have a Telecom Regulatory Authority of India, which is also responsible for the protection of the same in our country. So therefore, these are regulatory authorities. Basically, they control or they look after the telecommunication industries, that the users, the consumer, or the public interest is not compromised. Then we have internet standards. Now, in internet standard is a thoroughly tested specification that is useful to and adhere to by those who work in the internet. Now the internet standards is a standard which follows certain procedure that when something new comes up, there is a formalized regulation that must be followed. Now, for example, an internet draft may be put up for a new standard to be used in the internet. It may be put up as a draft, which is a working document or a work in progress. So that draft will be worked upon to review it and then re-edit it. Then ultimately, upon recommendation from the internet authorities, the draft will be published as Internet Draft and Request for Comment, RFC. So this is open for public comment, okay, or whoever is, capable of that. So this will be requests for comment will be edited, assigned a number, and made available to all the interest parties. So that way, internet standards also improves and it keeps on evolving. So these are some of the things that is about uh, protocols and standards. So with this, we have come to the end of today's class.